Hello, everyone. I'm your host, Ryan Murray, and I'm excited to welcome you to another session of our Advanced Air Mobility webinar series. Today's topic is Airspace Integration Assessment. We hope you will gain a better understanding of how the FAA, NASA, and industry are working together to take on challenges and provide solutions before AAM aircraft start flying in our airspace. Our presenters will discuss modeling and simulation in the integrated environment at the FAA Technical Center, integration activities at NASA, and the operational perspective of integration. We will also view a brief video about the Technical Center capabilities and listen to a panel discussion about simulation. Our panelists today are Adam Rhodes, NACA representative, Thomas Rubino, an IT specialist, and John Bradley, an air traffic control specialist with FAA, and Ken Goodrich, a research engineer with NASA. If you have any questions, please submit them using the YouTube live chat function, and we will have a few minutes to answer questions before closing today's webinar. Paul Fontaine, Assistant Administrator for NextGen, will get us started. The Office of NextGen has been a leader in advanced air mobility issues and is coordinating key projects around the FAA that will be required to integrate the new technology into our airspace system. Welcome, Paul. The floor is now yours.
All right, thank you very much, Ryan, and good afternoon to everyone. It's great to join you for this sixth session in our AAM webinar series. We really hope that you found these series informative, and we're really committed to doing more of these in the future to help provide transparency about what we're doing here at the FAA and the efforts. Today, I really wanted to talk briefly about the kind of work we're doing to make advanced air mobility a reality. Hopefully, your takeaway from this event today is that the FAA is ready, willing, and able to integrate advanced air mobility into the NAS. And we're really working hand in hand with industry partners to demonstrate what that will look like well in advance of any of these aircraft actually flying revenue operations. I also wanted to acknowledge the continued partnership that we have with NASA as we continue to leverage the collective investments across government towards advanced air mobility integration. So the FAA has had a pretty long, I think, successful history of safely introducing new aircraft into the national airspace. And our approach is to ensure as much maximum flexibility that we can within the existing regulations when it comes to integration. During this webinar, we will be showing you how we're using some of the world-class modeling and simulation capabilities at what we call the FAA's premier research lab, that is the William J. Hughes Technical Center. The first step in this process typically starts with us listening to the various use cases that our industry partners describe, i.e., what do they want to put into operation? And some of these operations will be in highly complex airspace, sometimes connecting very busy airports with city centers, say. So fortunately, that kind of environment lends itself perfectly to what we can simulate and what we can fly in advance using some of the real live scenarios and really using that time to examine all the interactions that will need to take place. Like I said, well in advance to supporting that operation in the field for real. So these simulations aren't really just about the AAM aircraft themselves. We also model how the air traffic controllers will respond to these new entrants from, say, a tower perspective, as well as other operators that'll be sharing that airspace or operating airport infrastructure. And just like the integrated airspace that we're all building to, hopefully you'll see how modeling and simulation technology that'll be demonstrated at our NextGen integration evaluation NIAC lab can be useful to this task. As the advanced air mobility segment of aviation continues to grow, we hope to share all these findings with our various industry partners and make sure that we can certify all the technologies that we need to meet the safety and efficiency standards, right, that the public has come to expect of us. So now we're going to share a short video that provides a pretty good overview of the Technical Center and more specifically highlights the various areas of this NIAC lab. So with that, we'll cut over to showing the video.
Hello, welcome to the Technical Center. Most of the work that we do here requires a laboratory that simulates the capabilities that are operational in the NAS. Our technical staff perform careful and thorough verification and validation efforts to assure changes to the system are operationally suitable and safe before they are deployed. It's only natural that these laboratories are used to upgrade, improve, and operationally sustain the national airspace system. The Technical Center cannot do it alone, and our partnerships with industry, academia, government, and international are very important to FAA as well as the Technical Center.
The ATM area simulates en route and terminal domains and includes both existing and future NAS capabilities. This area provides a realistic look, feel, and operation of the en route and terminal automation systems. The NIAC uses the field of displays, keyboards, trackballs, and knobs to immerse the participant into a realistic air traffic environment. This area is of course integrated with the rest of the lab, making everything interconnected. The NIAC Tower is an advanced tower simulation system. The simulation provides a 300-degree realistic display of aircraft and airport operations. This system can simulate day and night with various weather conditions such as clouds, rain, or fog. It can also support concepts such as unmanned aircraft systems, advanced air mobility operations, simulated safety alerts, and anomalies such as crashes, runway incursions, flames, and smoke. The out-the-window view currently supports many airports, such as Philadelphia, Denver, and Atlantic City, but can be configured to support any airport as needed. The Reconfigurable Cockpit Simulator, RCS, is a full-size, enclosed, configurable, and extendable glass cockpit with a 220-degree out-the-window field of view that provides visualization of traffic, weather, and over 18,000 airport environments. The RCS is built on a high-fidelity aircraft performance model and includes a mix of both tactical controls and display interfaces to provide a rich, simulated environment. The visual system offers highly realistic visuals including dynamic elements such as wind and traffic. It is also possible to add additional features and prototypes for testing such as an angle of attack indicator. The system is currently configured to be an Airbus A320 and can be viewed as a target on the displays in the tower area and ATM area, seamlessly including it into simulations and demos. The multipurpose area stays true to its name and has many uses in the lab. In this section, we have a multitude of different displays that range from weather to traffic management, and we will have those services running during simulations as needed, as well as displayed for demos and tours. A couple stations that remain static are used for our simulation control environment, which allows us to have a dedicated location for launching our human-in-the-loop studies, the tower view, our cockpit simulator, as well as other tasks in the lab. The NIAC Display Lab is a separate room within the NIAC that can be used for presentations and briefings before, during, and after simulations to support discussions with VIP observers and subject matter experts or SMEs. Additionally, the video wall is connected to all NIAC systems, allowing live simulation viewing for guests as well as replay capabilities.
All right, so hopefully, as you can see, using the NIAC lab, we really have a great tool for supporting what AAM will look like and examining the different possibilities of how they will fly. So the team at the Tech Center can really help bring to life operations such as advanced air mobility and other things, as you saw, and really provide a research environment that brings everyone together in a way that we can discuss and solutions in a tangible manner. That's really our goal here. So we've had an opportunity to run an initial cadre of industry members to the labs at the Tech Center. And we look forward to hosting more events in the future for others that may want to come and see for themselves how we're using these tools. In the meantime, the team is really preparing for some upcoming simulations, first focused on the Los Angeles area. And we'll also be conducting a lot more tabletops for additional airports where we expect to see some of those early operations. So with that, let me welcome Tom Rubino, who will begin the discussion. Thank you.
Thanks, Paul. Good afternoon, everyone. Today, my colleagues and I are going to discuss our modeling and simulation efforts in support of Innovate 28, Advanced Air Mobility, AAM. We are using our modeling and sim capabilities at the William J. Hughes Technical Center and with our partners to assess the integration of these new operations into the National Airspace System, the NAS. We call this part of our test and evaluation plan the Airspace Integration Assessment. We know that industry is very interested in the airport transfer use case. That's flying between downtown of a major city to that city's airport, usually a major airport. And I'm sure some of you have probably wished you could leave the traffic jam you're in and fly over to that airport and get there quickly. Well, that's what we're trying to do, make happen, and we're trying to make it happen in the near future. But it is complicated. This involves complex airspace with many rules, regulations, and safety concerns all need to be considered and worked through. So in order to effectively assess these things, we created an integrated environment. On this slide, we have the key components laid out. Starting on the left, we have the FAA's high fidelity systems that represent the NAS. This includes our terminal automation system, and it's the real system that is in the field. We have it into our simulation environment. It also includes an air traffic control tower simulation lab with voice communications and other tools that controllers expect to have. And not really shown here, but very important piece of this is our high fidelity simulation engine and infrastructure kind of makes it all possible. We are also integrated with our Mike Maroney Aeronautical Center in Oklahoma with one of their high fidelity Level D cockpit simulators. It's fully equipped and integrated into our simulation environment. On the right, for advanced air mobility, we partnered with NASA, who brings in advanced prototypes to represent the AAM ecosystem. This includes AAM fleet operations, vertiport scheduling, and AAM aircraft models and simulators. You'll learn more about this from my colleague from NASA a little later. We run these distributed simulations in this integrated environment on a weekly basis in coordination with our partners. I'd like to point out that this environment is extensible and we continue to add capabilities as needed. We also understand that industry plays a key role, and so towards that, we have several industry partners going through the onboarding process so we can integrate and further include them in this effort. Before we leave this slide, I would like to introduce John Bradley, our lead air traffic control specialist, to discuss this environment from the controller's perspective. He'll discuss how we use this environment, give some examples, and explain why it's an important part of our airspace integration assessments. John?
Thanks, Tom. Appreciate that. Yeah, so I'll just sort of piggyback a little bit on what Tom had to share. And so on the left-hand side, we have a view of some of our capabilities here at the Technical Center, the out-of-the-window view, control tower simulator. Right now, that picture is displaying LAX airport. We're in the middle of a simulation that's going on there when they took that picture. One of the first things that we do before we even get started on a simulation is to take a look at existing traffic at the airport. We go in and look and do a dive to see what a day in the life looks like at, in this particular case, LAX, and start the simulation from there. We want to make sure that we have the accurate background traffic before we start to introduce new entrants so that we have a good idea of what the interactions may look like. One of the biggest things about this lab that makes it a high fidelity environment is that we use existing fielded NAS systems. And so the voice switches that we use in the tower cab that we use to communicate with pilots and between controllers are actually fielded voice switches that are used in the field today. The stars display, the radar display in the bottom half of that left-hand picture, that is a fielded system. It comes with an incredible amount of capability. Each facility creates their own local adaptation in their stars platform to use based on what their airspace, how their airspace is configured, how their runways are configured, and what their needs are at the facility. So when we run the environment, we're looking at a day in the life background traffic. We're using stars systems that are fielded with local adaptations. So we want to create an environment that's as close to real life in the field as we possibly can. So I'll move on over to the middle picture there, looking at cockpit simulators and sim pilot stations. So the controllers, the pilots that we're talking to in this environment are either in a cockpit simulator or basically a pseudo pilot flying keyboard. But they have voice capability. and they have the ability to turn and climb target aircraft. In this particular case, and Tom pointed out a little bit earlier, the bottom half of that center picture is the Mike Bernerney Aeronautical Center full motion cockpit simulator. It comes with a full suite of avionics. The one thing that we like about that specifically is the TCAS capability that our pseudopilot stations do not have. So when we have these aircraft, these new entrants, advanced air mobility, flying potential ingress and egress routes in and out of LAX, having this capability to see if we are generating potential TCAS alerts is something that is of interest. The right-hand side is basically showing some of our colleagues at NASA Langley Research Center, their capabilities there. So in our environment, during our scenarios, all the advanced air mobility aircraft are being flown by NASA Langley. And it's either in their cockpit simulator, which they have named a Flyer. You can see the person on the bottom is actually in one of the simulators. It has a flight control panel there, as well as an out of the cockpit view. So they have two of these Flyer simulators that they fly in the environment, as well as several pseudopilot stations, again, keyboard pilots in this environment. So before I go to the next slide, I'm going to show you a short video of a scenario, human in the loop scenario that took place. It was a dry run for LAX. And so what you're going to hear is the female voice is a controller at LA Control Tower, and she's working the helicopter position, basically working the advanced air mobility aircraft that are in this scenario. So it's a short clip. You're going to hear some pilots get delayed for departures coming off of the North Complex runways, and some aircraft that are going to be holding for the eVTOLs to depart. So I'll just let the clip play and explain itself.
City 9104, airborne, passing 300.
City 9104, roger, traffic will be holding position 24 left.
City 9104, roger. Tower, City 4513, ready for departure, pattern 2, and information alpha.
City 4513, LA Tower, roger, hold position for traffic departing 24 left.
Hold position, City 4513. LA Tower, Pacific 6704, inbound, Sepulveda with alpha.
Pacific 6704, LA Tower, proceed inbound.
Proceed inbound, Pacific 6704.
Okay, so that's the short clip. So you can hear the exchanges that are taking place between pilot and controller. You know, one of the nice things about our capability is, you know, we record everything, so we can go back and play back scenarios, hear the exchange, and we're collecting a lot of data and metrics as well with the simulation. So if we want to go back and look at how many transmissions took place in each scenario, the length of transmissions, you know, we have, you know, a suite of tools that we can go back and do a data reduction and analysis to look at, you know, specific metrics that we want to look at. So, and I'll just point out that the alarm that you were hearing in that short clip was there were a couple of AAM aircraft that had departed the airport and that were in en route phase north of the airport. It was a conflict alert that went off. It was a STARS conflict alert. It's something that was sort of out of the environment as far as directly at the airport, but it is a capability that we want to have, and that is of interest to us. So that's what it sounded like. So on this particular slide, again, on the left-hand side is our out of the window control tower simulator, 300 degrees. We're looking at LAX. This is a simulation at LAX. We're facing east. The north complex is on the left-hand side of the picture. The south complex is on the right-hand side. You can see people in the back that are sort of watching the environment and sort of observing the operation as it's taking place. So, it really is, when you're in the environment, looking out of the window, it looks like you're in the control tower. From experience, people that have been there, they basically, it's about as real as it can be. And so being able to look at the interaction between advanced air mobility aircraft, the legacy traffic in an environment like this is hugely beneficial. The center picture is of JFK Airport. We're doing work with NASA, actually supporting them in the midterm and beyond, looking at potential uses of digital communications for Class Bravo clearances. So we are supporting them with that effort, and we have a simulation coming up with them at the end of the month. On the right-hand side is another picture of one of the flyers, cockpit simulator. You can see the out of the cockpit view. It's on final approach, just getting ready to touch down at a central terminal area, vertiport there at LAX. And if you look at sort of the bottom of the illustration there, that's a trajectory that it just actually flew. So it came in from the north, and then it had to execute a little bit of a pattern before it got to this point because of the steep trajectory that was required. So, having accurate aircraft performance models and what trajectory they could actually potentially fly is important for the environment, as much as existing background traffic and having that accurate as well. So what I'm going to do is, I think this is a good point to turn it back over to Tom, and I'm going to let him finish up on this slide. Tom, back to you.
Thanks, John. All right, so yeah, I'm going to talk about the bottom part of this slide. Along the bottom, we have a high-level summary of our modeling and sim process. This is a key part of our support to getting these new operations safely integrated into the NAS. We use an iterative building block approach, starting with collecting data on current operations, as John mentioned. We define assumptions. We also include input from industry, airport authorities, and other key stakeholders. From there, we run a series of fast time simulations where we can rapidly develop a set of scenarios we feel could be safe solutions for these AAM operations. These fast time models and tools allow us to do a whole lot of what if scenarios. We collect metrics, and ultimately they help us create a very realistic set of simulations that we then take into this integrated environment we just spoke about, and we run our human in the loop simulations. Now, all along the way of this process, we work with a team of FAA subject matter experts. They come from different lines of business, all there to help ensure that we don't miss any critical aspect that needs to be considered. We feel this process is solid. Our modeling and sim tools and this integrated environment enables our researchers and testers to apply proven scientific methods to collect qualitative and quantitative data, and ultimately allow us to determine the suitability of these proposed AAM operations. So now I'd like to introduce Ken Goodridge from NASA Langley Research Center. He will discuss in more detail NASA's role in supporting advanced air mobility and our modeling and sim activities. Ken?
All right, great. Thanks, Tom. As Tom said, I'm Ken Goodrich. I am with NASA. I reside at the Langley Research Center, but work with NASA colleagues at Glenn, Ames, and Armstrong Flight Research Center. So it's a national team supporting this work. I am the Deputy Project Manager for Technology of the Air Mobility or Pathfinders project. It's one of several projects at NASA that have significant content focused on advanced air mobility. Let me just briefly run through some of the other projects. First one is our RVLT, or Revolutionary Vertical Lift Technology Project. It is focused on the development of vehicle technologies with particular emphasis on things like vehicle noise and community acceptance, aircraft safety, including things like crashworthiness and reliability of the distributed electric propulsion systems, as well as advanced design tools to help aircraft developers be more efficient in the development of these advanced concepts. The other projects that I'm about to mention are all under the Airspace Operations and Safety Program, which tends to be NASA's program that has most contribution to airspace integration and works closely with the FAA. So the projects here include the system-wide safety project, which focuses on design and operational safety research with emphasis in the areas of advanced assurance methods for emerging complex systems, things like machine learning and artificial intelligence. It also has a project area looking at in-time aviation safety management systems to be able to take advantage of our increasingly networked and data-rich environments to help improve aviation safety. Next project is the ATMX, or Air Traffic Management Exploration Project. It is focused on research that broadly supports the advancement of the NAS in the future. It has activities focused on increased exchange of digital information across the various actors of the system. So supporting a common or integrated operating picture across the various decision makers of the system. It's also looking at advancing a extensible traffic management framework that supports a wide range of new entrants across the NAS, not just advanced air mobility. And then finally, it has a sub-project known as Pathfinding for Airspace with Autonomous Vehicles, which is looking at the introduction of remotely piloted advanced aircraft operations, starting first with fixed-wing crewed vehicles, fixed-wing cargo vehicles, excuse me. And then finally, under AOSP, there's the AMP project, or Air Mobility Pathfinder project, where I reside. And the focus of our project is doing a deep dive into urban air mobility, which is one of the missions under the AAM umbrella. And in that deep dive, we're focused on looking at accelerating the progression of advanced air mobility from entry into service into the midterm stage, and paving the way eventually for mature operations. So a key focus here is looking at the scalability of AAM beyond entry into service, and some of the important characteristics of that more scalable operations is, first, of course, is looking at higher frequency operations, so more vehicles taking off and landing from a given vertiport, as well as potentially closer densities in route operations. Along with that, being able to support more complex vertiport and route networks, having increased robustness of the operation. So, for example, being able to operate in reduced visibility conditions, not just clear day weather conditions. And finally, the integration of piloted and remotely piloted aircraft. And of course, along with these advanced operating capabilities is the need to consider future procedures and regulatory updates. And I should emphasize, as I say that NASA is a research organization, so we don't directly make any sort of regulatory decisions. But what we do is help inform the broader community when we're in a situation where there is a need to update procedures or regulations to allow more advanced operations. And in terms of our focus on midterm AAM operations, we're being guided by the FAA's UAM CONOPS that is available on the web. We work closely with the FAA, of course, but also a broad range of industry partners, cross-vehicle developers, prospective operators, and also looking at service suppliers for AAM operations, often known as providers of service for UAM, the PSU developers. Significant aspects of our research look at the development of cooperative operating practices. A goal of these practices is to be able to shift some of the burden of managing AAM aircraft from the traditional air traffic control system to be more self-managed by the operators themselves. This reduces burdens on the ATC system so that the impact on traditional operations is minimized. Significant part of this, as I mentioned, is the increasing introduction of third-party services that help support operators and management of the UAM network resources. Our overall project has a objective of providing recommended requirements, reference functional architectures, and validation data assessing the feasibility and accessibility of an extensible traffic management system, data exchanges, and operational procedures to safely enable scalable advanced air mobility through the midterm stage per the FAA UAM ConOps. And I just want to briefly touch on the graphic here showing some of the capabilities at NASA, and just going clockwise around the slide, starting from the upper left. One of the things that we do is modeling of advanced vehicle capabilities. This modeling is coming out of that RVLT project that I mentioned earlier. They provide reference configurations that can be used by the airspace integration community to look at the emerging capabilities that may need to be accommodated in the airspace. Then over on the upper right, we've got a variety of development and evaluation labs on the surface. These can look similar to what Tom and John described at the Tech Center, but an important difference is typically these are not fielded systems, which makes it, they're more tailored to be able to model and evaluate advanced concepts. Some of the capabilities in his presentation, Tom mentioned 2 flyers involved in the current study work. We actually have an additional room that has 10 additional flyer cockpits, so the number of flyers can easily be scaled up as needed. We recently completed a study looking at non-towered vertiport operations with those 10 seats manned. In the upper right portion of this slide is our Future Flight Central tower, which was used as, it's a tower simulator. It was used in a study of operations in the DFW area with the introduction of potential midterm procedures to simplify communications between aircraft and controllers. It was recently reported on in an article in the Air Currents magazine, if people are interested in learning more about that. Just quickly finishing up here, coming to the lower left portion of the slide is a high fidelity full motion facility simulator. This is known as a vertical motion simulator, and it is actually optimized for simulation of vertical takeoff and landing aircraft. It's the world premier facility for doing those evaluations. And we've both looked at supporting the development of certification means of compliance for the pilot vehicle interface in that facility, as well as looking at considerations about passenger ride quality. And then finally, closing the circle on this slide, The Joby aircraft is part of a partnership with the Air Force and the FAA to collect data on the Joby's aircraft to help validate the simulation work that we're doing, and also to be able to integrate flight vehicles into our overall validation activity. So we can integrate live flight aircraft into the broader simulated environment to increase the fidelity of those assessments. So with that, let me hand things over to Adam Rhodes, who will help give us more insight into the operational integration perspective.
Thank you, Ken. I appreciate it. My name is Adam Rhodes. I am the National Air Traffic Controllers Association National Representative for NextGen. NATCA, to take a moment here, we represent nearly 20,000 air traffic controllers and other aviation safety professionals that also include aircraft certification specialists, airports division, engineers and architects, flight procedures, flight service, and traffic management. So we have a lot of experts to lean on in the successful implementation of AAM. We're dedicated to furthering the public's interest in safe and efficient air transportation, and we seek to preserve, promote, and improve the safety of air traffic in the United States, and look forward to the opportunity to help find solutions for these new entrants. And for those that maybe have just joined or joined late and wondering what we're all talking about, it's advanced air mobility. And to break it down to the simplest terms, flying Ubers or Lyfts, electric vertical takeoff and landing aircraft capable of carrying passengers from one location to the next. So it's a new mode of transportation, and very exciting to play a part in what that would look like in our national airspace system. Wanted to hit on a few points of our early involvement from the air traffic operational perspective with advanced air mobility. The collaboration, first and foremost, with the FAA has really been key for us to be early in the involvement to ensure the feasibility of the concept. We're introducing a new mode of transportation into the national airspace system that has to now interact with all the existing modes of transportation. And we have to do that and meet the threshold of safety that that our passengers and the flying public expect from us. And that's a very high bar, and we take a lot of pride in ensuring that we do have the public's trust to move traffic safe from one coast to the next. Involving local expertise as soon as possible just ensures that both safety and efficiency are met. Each airport and airspace have different nuances. And you can be very familiar on the outside looking at an airspace and airport configuration, pulling up charts, but until you get into the operation and discover all the nuances and how there are so many things in the operation that will be dependent upon something else. So when you make one change, you actually have to make maybe 2, 3, or 4 changes to ensure that it's successful. So you have to consider a lot. There's a saying in the aviation community, if you've seen one airport, you've seen one airport. And that really speaks to the different runway configurations, airspace configurations, standard operating procedures, letters of agreements. And again, airports that can even be dependent upon each of each other from in major metroplexes. Realizing when you do this and involve that early insight that can point out these specific nuances, you really get a sense of how to inform future decisions on how OEMs may operate on airport, how the local airport authority and local government could leverage the information or research from some of these early challenges we may face looking for solutions. And really wanted to pivot to what we're doing, what we're talking about today, and that's the FAA Tech Center and the capabilities. And I feel that, no offense to the ones that came before, but maybe you're just being humble, but it is absolutely fascinating what they can do at the tech center here in Atlantic City. I'm actually sitting at the tech center as we speak, running another event with the FAA, but to see what can be accomplished, and the fact that it promotes one of our main objectives of promoting safety in the national airspace system, but they can actually recreate a real day of aviation traffic at any airport in the national airspace system. And not only can they recreate that environment where you see it visually in a control tower, you see it visually on a terminal radar display, you see it visually on an en route radar display. Not only can they do that, but they can pipe in other pieces of technology as simulators, and now you can insert yourself first person into this simulation that's based on real traffic, and you can do things that you couldn't do in the NAS. You can operate an aircraft maybe a bit more rigid. You can really bend and try to even break the system, is what we do in these labs, and we can do it safely. And so we're able to take OEMs and actually put their specific aircraft into the simulator. We're able to take existing airframes, as they spoke about earlier, Airbus and Boeing airframes, and put those into the simulator and interact with these new modes of transportation that we're trying to introduce as well. So just the capability there alone is incredible. And it is the systems that we use today, the software and the hardware. So there is no higher fidelity place that we can operate that. Just in closing, we really do, the National Air Traffic Controllers Association embraces the challenge, and we are excited to integrate these new technologies. They'll enhance our working conditions of our members, and will also uphold the safety of the NAS like we always have. We encourage, we encourage OEMs, airports, the FAA, other industry partners to bring your ideas, but also be open to other ideas and other interests, and understand our workforce will do whatever we can to find solutions that are safe in the NAS. That's what we do. We do that every day. We're pretty good at it. So take a lot of pride and again, upholding that level of safety that our customers, the public, deserve when they're flying. And we appreciate our partnership with the FAA in doing so. And I will turn it over.
All right. Well, thank you to Tom, JB, Ken, and Adam for your informative presentations and panel discussion this afternoon. It's very interesting to learn how we're using modeling and simulation to enable the safe integration of advanced air mobility into the NAS. So now we have some time to answer some Q&A about today's topics. If you would like to ask a question, please use the YouTube live chat function at the bottom of your screen, and we'll go ahead and get started. So our first question is, can this simulation environment also support mid and mature state AAM operational assessments and research?
Yeah, Ryan. So I'll start with that. I think JB could add to it. Yes, most definitely. We are currently using this environment, supporting a NASA mid-state research effort. And what they're doing, takes place in the New York area around JFK Airport. They're focusing on midterm research around digital communications, AAM, strategic deconfliction, and some other capabilities. So we are using it currently for further out research. JB, do you want to add to that?
Sure. So so the Innovate 28 effort that we've worked on for LAX and other airports that are in the pipeline is looking at the near term and the here and now. But we do actually, there is an interest for midterm and beyond. And so as Tom pointed out, that is, NASA has a focus on that. And so supporting that digital communications outside of the CPDLC and the TDLs that currently exist in towers across the country. There's potential capabilities for something other than that, and that might be available on a electronic flight bag, something that's IP based, obviously secure, but that is something that is of interest to help, reduce frequency congestion and control the workload. So that is definitely something of interest. We have the capabilities in our lab. Like I said earlier, we enjoy using the existing systems with their local adaptations, but we also have the capability to emulate new systems that are getting ready to come online. So we have an incredibly talented staff here at the Tech Center that can code up capability based on requirements that come out of discussions, tabletop exercises, and something that we think may be of interest to introduce into the lab. I guess I'll close there. I'm not sure if Ken wanted to add anything.
Yeah, well, I just want to, foot stomp some of the things that both you touched on, John, as well as Tom, and that is an important part of AAM is being able to support the evolution of the NAS at the pace the industry is able to perform. And part of that is understanding what that trajectory is going to look like from initial operations into the midterm stage and mature, so that we can start getting into place procedures, rules, and regulations that allow the industry to be able to scale. So being able to look across those operational stages is extremely important. And yes, we are leveraging our tools to be able to do that.
Yeah, it sounds like there is a long list of capabilities that can be used with these simulations. So we thank you for your responses to that. Our next question is, what is the most surprising thing you have learned about airspace integration since you've been testing LA airspace?
I'll take a stab at that, Ryan. So, we've been working at LAX for quite a while now, several months. And so, again, the first thing that we typically do is we go in and look at how does the operation exist today? So we go into look at the facility through a directives repository. How do they operate today? What does it look like? What's a day in the life look like today? And so, one of the things that sort of jumped out, LAX, ranks in the top 5 of one of the, busiest domestic airports, routinely. But the footprint of the airport is relatively small. So when you look at, they have 4 parallel runways, the footprint is relatively small compared to other Core 30 airports in the NAS. And so when you look at the distance between the outboard runways, extended center lines, you're right around 6,000 feet, which is a little more than a mile. And there's not a lot of development that's outside of the runways. The south side of the airport has some ramp space there with fixed space operators and some cargo operations, but most of the operations that take ramp space and infrastructure is within the central terminal area and inside the runway complex. So that makes it a little bit more challenging, being sort of tightly confined. So in a perfect world, you have lots of space. You can develop procedures and routes that strategically deconflict from, legacy traffic. But when you're tightly confined, it makes it a little bit more challenging. So, but having the environment that we have are helping us answer some of those questions. And so I guess that would be my take on that question.
Yeah, and as Adam said, if you've seen one airport, you've seen one airport, right? So if you went elsewhere, it'd be a completely different experience. But thank you, JB, for your response to that. Our next question is, why is it so important to use a high fidelity simulation environment?
I'll take that, Ryan. It has to be. That's how important it is. This is real world applications. The aircraft are here. They're going through certification, and we have to be prepared as to what that'll look like when they're able to scale and fly. We have to ensure that our operation procedures I spoke to earlier and systems can safely support that. And the only way we can do that without the aircraft flying in the actual NAS and uphold that level of safety that we all are privileged is to do it in a simulator like this, to take our real life simulators, to take the actual air traffic controllers from LAX and fly them all the way across the country to Atlantic City, just so we can get the perspective in that environment from the air traffic controllers. I spoke a little bit earlier, but just mitigating risk, that's safety is our focus in the FAA. And in order to, again, incorporate these new pieces of technology, you have to do it in a safe environment. And an environment like this that can mimic all our real world equipment, it allows us to do that. It allows us to operate in a way maybe we we wouldn't want to attempt in the real world, but it can push the system. It can push those, really find those pinch points where the operation can no longer support maybe one of these new entrants, and maybe where we can identify earlier where to look that maybe could more conducive to operating that vehicle more successfully. And it gives us data. That's the beautiful thing about we have all this data now that we can go back to and analyze and replay, as JB said earlier, and continue building off of it and really fix the problems real time. I mean, we've been out here already to the tech center and had an issue, went to lunch and we came back and the issue was resolved. And that's just a lot of thanks and appreciation to the people at the tech center, that the entire team that put that together to make it possible. But at the end of the day, it has to be that high fidelity. That's what you all expect.
Ryan, if I can join in there, I think that this is, I think, something unique tools and opportunities that we have for these initial sites. I think, there's such a newness to all of this for everyone, right? We've never seen one of these really fly or operate. It's a very unique, new type of aircraft, and hence why, we've adjusted our rules and everything to acknowledge, right, that there's a new form of powered lift aircraft that'll be in their NAS. So, but as we get through these few couple of sites up front, the hope there is that becomes more routine to everyone, right? And that as we go to more airports and more locations down the road, we may not have to put as much of this effort into it because people will be familiar, and it'll just be one of those things we can replicate into more locations quicker. But up front, this just gives us that, unique time to be able to say, hey, we have these capabilities. We can do these early looks. Really, it's about building common understanding, right, for everyone, making sure that we all know how this will look in the operation and getting everyone used to the new look and feel of it. And once we get to that point, I think we hit the tipping point and we're able to get operations going quicker at a lot more places.
Yeah, that makes complete sense. Thank you, Adam, for your comments, and Paul for your input as well. Moving on to our next question is, for example, I'm an OEM or a stakeholder. How can I get involved in your research?
Thanks, Ryan. I'll take that one. So what we do is we start by establishing a cooperative research and development agreement. We kind of use the acronym because it's easier to say, the CRADAs. And we establish these agreements with industry. We already have a few underway, and we welcome others to engage in a CRADA with us. I think we could probably provide a POC. We have an outreach and partnership branch that usually starts off the whole process, the CRADA process. So that would be how I would advise the OEMs or stakeholders to get involved with us.
I'll just add, at NASA, it's a pretty similar process where we have a combination of just general interactions with people in the industry, that those interactions turn into Space Act agreements that allow us to do cooperative research with those participants. We also occasionally have what we call an announcement of collaborative opportunity, which is a broad announcement to the community with a specific upcoming opportunity to partner with the government and solicit inputs to that ACO to find the best matches between NASA and industry.
Okay. Well, thank you, Ken and Tom, for your input and guidance for those interested in getting involved. Move to our next question, which is from Kirk Hoteling. Kirk asks, and says, great presentation, thank you. Many vertiports that get introduced will not be on airports. They will be in downtown centers and communities, for example. How will the FAA model these kinds of situations?
Well, I'll take a stab at it to start with. And I'll use our LAX work to help me do it. So we made some assumptions. We wanted to model a realistic environment. So we do have vertiports outside of the airport coming from downtown LA and as well as Van Nuys Airport in order to make up routes for our simulated fleet operators. And so the model is very specific. Can be very specific as we tell it to. So we could describe the fleet, how many aircraft the fleets have, how many fleets are flying in this operation, and a lot more detail on the vertiports within the whole routing system. So we made a lot of assumptions in the beginning because we didn't have all the data from industry. As we start to learn what industry wants to do in LAX specifically, and this would apply to any airport, we will adjust our simulation model, and I think we'll cover those type of vertiports in that environment, flying to and from a big airport like LAX. So that's my best answer. I don't know if anyone wants to add to that.
Yeah,
Go ahead.
I was just going to tag on to this to say, obviously there's an expense to what we're doing here. And we've sort of preserved the use of these kind of tools where we see complexity, right? Of where we're trying to take, significant busy airports and then interject a new form of operation into it. That's not to say that we have to do modeling in sim for every operation that various companies may be looking at in the future. If you're operating, say, at a GA type airport in not, busy airspace, we may not have to bring the same kind of resource, right, to be able to support that. You just may be able to go fly that operation. So we're just going to kind of draw the line on the more critical ones and see how those go case by case.
And while the question was aimed at the FAA, let me add from NASA's perspective that we've done some initial research into vertiport operations. I mentioned looking at the ability to apply non-towered procedures to a vertiport to understand what the throughput of that sort of facility might be, what the limitations are, and where there's the opportunity to inject technology to improve both the performance and safety of those operations. We also have a ConOps that's available for download for a future automated vertiport management system. So I encourage folks who are interested in that to look for that document. And sort of building on what Paul said, we're looking at some of those longer lead activities as it gets to actual deployment, having those interactions with the FAA to support the actual introduction into the NAS will be important, and the requirements to do that is going to depend on the complexity of the environment that operators are trying to fit into.
Understood. Well, thank you, Ken, for the NASA and also FAA input and perspectives as well. With that said, that's all the time we have for today's Q&A session. But I just want to say thank you again to John, Ken, Tom and Adam for today's webinar, as well as Paul. Your input is always appreciated. And we greatly appreciate everyone's attendance who was able to join us for today's update. Please visit our website at faa.gov/air-taxis for the latest updates, including information about future webinars. Thank you, and I hope you all have a great day. Take care.
Thank you. Bye-bye.